Hey guys, I'm going to walk you through this week's lab activity. We're going to use this program a few times. It's called Physics Aviary, and it's a little bit different. Um, so I just want to make sure everybody understands what to do here. So once you open your lab, obviously it gives you some information. And it's really important. It keeps saying only submit a successful trial. So essentially, this program is going to give you a situation, and you're going to have to make some calculations and then enter to see whether you got it right or wrong. Every time you enter it, you have to start over again, and it'll give you a new situation. So please be sure to check your units, check your measurements, check your calculations, because otherwise you'll get a new set of numbers and pretty much start over again. All right, so the cool part about this is it does require you to put your name in here. So if I put Roman, okay, it gives me this situation. So this is an electric field. This is called simple because it only has one charge. All right, and right over here, this yellow, it says measure the distance from the charge to the yellow electric field sensor. So that's little guy right here. I mentioned this in my weekly video lecture as well. And I kind of show you how to do a little bit of this, but I want you to understand this program as well. All right, and so this is measured in centimeters. And notice your distance here is asking for centimeters, but when you calculate electric field, you have to convert to meters in order to get to that. All right, and remember the easiest way to do centimeters to meters is to think about money. Okay, there's 100 cents in a dollar, just like there's 100 centimeters in a meter. So when I do this, I'm going from about 24 up to about 74. So I'm doing math in my head, 50 centimeters. So if I had 50 cents, right, that would be $0.5. So if I have 50 centimeters, I'm going to have 0.5 meters. So nice, easy peasy metric units here. All right, then I'm going to go ahead and calculate my electric field using the fact that this is a source charge, but also notice that this is a nano. Okay, and so in order to go from nanocoulombs to regular coulombs, we're going to do, mine will be 43.9 times 10 to the negative 9, right? Because nano means negative 9. If you need a refresher on metric conversions, I do have a little video in the physics resource at the bottom of our course page. All right, and so I'm going to plug all those numbers in. I'm just going to make something up here just to show you what happens when you get it wrong. All right, and then I'm going to decide what direction it is going based on the fact that this is a negative charge. So in this case, it's going to be going in that direction. So I'm going to pick rights, although I'm terrible at my lefts and rights. And I'm going to check, okay? And so notice right here it says Roman. So that's why I had to enter my name. So you can't just take somebody else's screenshot. Okay, and so clearly I did not get this right, but when I look at my actual answers here, okay, my distance was correct. I predicted 50 centimeters, it was 50 centimeters. My electric field, I just guessed, I didn't even try to calculate it, and so clearly I'm wrong on that. And then my direction was correct as well. So I'm going to be looking at this. Sometimes it can be kind of picky, so notice that this is 5 significant figures. So if you are really close, like let's say you had, I don't know, 66.4, okay, which is a little off than this, and it told you it was wrong. That's kind of within reason, but it's usually pretty good if you keep your significant figures throughout this, all right? And so the problem with this is that if then we start over again, I got to re-put my name in here, and I'm given a completely new situation, okay? Then we're doing a very similar thing for part 2. However, it is not the simple version. It is the slightly more complicated version, which once again, you put your name in here. And now we have 2 charges. So this is an example of what I used in your video notes this week. So I have to find my yellow sensor. It's way over here at the 74 mark again. And so I'm doing 2 calculations. All right, one, I'm figuring out what the electric field based on Q1 is, and then I'm figuring out the electric field on Q2, and then I'm deciding, are they working together or working against each other? All right, if they're going in the same direction based off of this location, not just in general, because if I take this yellow dot and move it over here, my answer would be totally different. All right, so you have to decide, are these working in the same direction or opposite? Draw those arrows out just like I did in the videos. It'll help you understand that. And that way you can decide whether you're adding or subtracting. Also, when you're using um, these charges here, use the absolute value. Because again, if I put this charge on this side or this sensor on this side versus this side, I'm getting a different answer in terms of the direction. All right, and then you're going to figure out that direction and click check and take a screenshot of that. All right, so once you have your screenshot, that is when you're, or once you have your correct answer, that is when you're going to go ahead and fill out those variables there based on what the program gives you. Okay. I hope that helps. And again, please make sure you're paying attention to those little details so you don't have to do this a whole bunch of times.